Welcome back to math. These are the practice problems for section 18, exponents. We'll start with problem number 1. It says 4 to the third power plus 5 to the second power, or that's 4 cubed plus 5 squared. 4 to the third power is 4 times 4 times 4, which would be 64, plus 5 squared is 5 times 5, or 25. Adding those together, we get 89. Problem number 2. 16 to the 1/2 power minus 3 to the 0 power. Well, first of all, 16 to the 1/2 power is the same thing as the square root of 16 to the first power. And anything to the 0 power is 1. So the square root of 16, there are actually two of them, right? There's -4 and +4. So we're going to have two answers. The first one is -4 minus 1. That's going to equal -5. And the other one is going to be 4 minus 1, so that's 3. So the answer to this is either -5 or 3. Problem number 3 asks us to find the square root of 5 squared times 2 squared. Well, there's a couple ways to do this. Let's start with this. 5 times 5 is 5 squared. That's 25. And 2 times 2, that would be 4. That would be 2 to the second power. 25 times 4 is 100. And of course, the square root of 100 is either plus or minus 10, positive or negative 10. Problem number 4 reads 4 to the -2 power plus 2 to the -4 power plus 2 to the third power. Well, a negative power means to take the reciprocal of the base and then raise the base to that power. That would be 1/4, the 4 squared. This is also a negative exponent, so it's going to be 1/2 to the 4th. And of course this is 2 to the 3rd. 2 to the 3rd is 2 times 2 times 2, and that would be 8. 1/4 squared is 1/16. And 1/2 to the 4th, that's 2 times 2 times 2 times 2, that's also 1/16 plus 8. That would be 8 and 2/16, or we can simplify that fraction to 8 and 1/8. Problem number 5 is 25 to the -1/2 power. So it's a negative exponent, so we need to take the reciprocal, and the reciprocal of 25 is 1/25, and then we need to raise 25 to the 1/2 power. So that's 1 over the square root of 25. There are, of course, two square roots of 25. 5 times 5 is 25, and -5 times -5 is 25. So this can be either 1 over a +5 or 1 over -5. We might also write that as positive or negative 1/5. Problem number 6 is 6 times 6 cubed. Well, we're multiplying this. It's understood that there is a power of 1 there when it's not otherwise specified. So when we're multiplying the same base, we add the exponents. So that would be 6 to the 1 plus 3, or 6 to the 4th power. 6 times 6 times 6 times 6 is 1,296. Problem 7 is 5 to the 3rd divided by 5 squared. When we divide the same base, we can subtract the exponents. So this is going to be 5 to the 3 minus 2 power. And of course, 3 minus 2 is 1. Anything to the first power is itself. For problem number 8, we're asked to take 4 squared and then square it again. But when we raise a power to a power, we multiply the two together. So this is 4 times to the 2 times 2. 2 times 2 is 4. That would be 4 times 4 times 4 times 4, and that is actually 256. Problem number 9 is to take 36/16 as a fraction and then take the negative 1/2 power. And you notice this is all in parentheses, so the whole thing is to the negative 1/2 power. So it's negative, so that means we're going to start with the reciprocal. So we are going to put 16 on top and 36 on the bottom. Now the 1/2 power is actually the square root. So we're going to take the square root of this whole thing. The square root of 16 could either be 4 or negative 4. And the square root of 36 could be positive or negative 6. So this simplifies to either positive or negative 2/3. Problem number 10 is multiplying the term 4y times a trinomial. So we have to multiply each part of this, each term of this, by 4y. So first of all, this would be 4y to the 5th. That's because this is understood to have an exponent of 1, and when we multiply the same base, we add together. Next, we're going to multiply 4y times y squared. That will give us a coefficient of 4, and then this will be y1 plus, well, y to the 1 plus 2. That's y to the 3rd. And then, of course, multiplying this term, 4y times 3, it's positive, that will give us 12y. Problem number 11. We have 2x squared minus 2 on the top of this fraction and x plus 1 on the bottom. I think we should start by removing the common factor of 2 from this top. That's almost always a good place to start. And when we do that, we get 2 on the outside and then 2x minus 1 on the inside. If you'll notice, this is a difference between perfect squares, and so we can factor that pretty easily. That's going to be x plus 1 and x minus 1. Now we have x plus 1 as a factor of the top and x plus 1 as a factor of the bottom. So we can remove those, factor them out, cancel them out, and we are left with 2x minus 1. In problem number 12, we have 24x cubed y squared divided by 6x squared y. So let's separate the parts of this so that we can see them more clearly. What I did is I isolated just the numerical part of this, the factors that are numbers, and we're left with 24 divided by 6. That's, of course, 4. Now we're dividing the same term, so we can subtract the exponents. This would be x to the 3 minus 2, or x to the first, or just x. And this likewise is y to the 2 minus 1, which would just be y to the first, or just y1. So we're left with just 4xy. In this problem we have a fraction divided by another fraction. And remember, to divide fractions you actually multiply by the reciprocal. So what I've done is taken the reciprocal or flipped over this second fraction. Now we have a bunch of common factors here. I'm going to factor this out times m times 4 times 6. So I've factored 9 as 3 times 3. M squared is going to be m times m. And I chose to factor 24 as 4 times 6. It's because on the bottom we have 4 times 3 times m. Now there's a 4 here and a 4 there, a 3 here and a 3 there, an m there and an m there. We're left with really just 1 on the bottom, and 3 times 6, that would be 18m. Problem number 14 asks us to put this decimal into scientific notation. We want to move the decimal point until we have it be so that the base is greater than 1 but less than 10. So we have 4.25 as our base. times 10, and we moved the decimal, let's see, 1, 2, 3, 4 places to the right. That would be a negative 4. Problem number 15 also wants us to put into scientific notation 5,844. Well, the decimal point is actually there, even though it's not written, so we have to move it 1, 2, 3 places to the left. We're left with 5.844 times 10 to the third. Remember that this is more than 1. We're going to wind up with a positive exponent here. If it's less than 1, we're going to have a negative exponent. Problem number 16 is some division to be done in scientific notation. So let's start by putting, this is 3.5 million into scientific notation. That would be 3.5 times 10 to the, let's see, 1, 2, 3, 4, 5, 6. And then we're going to divide it by, we have to move this over a couple of spaces so that we have it, the base needs to be greater than or equal to 1 and less than 10. So that's going to be 7 times 10 to the negative 2. Now we just divide 3.5 by 7, and we'll find out that that actually goes in 0.5 times. Now we're dividing common bases of 10, so we are going to subtract the exponents. So that would be 6 minus negative 2. 6 minus negative 2 is the same as 6 plus 2, so we have 0.5 times 10 to the 8th. Problem number 17 deals with logarithms. This one doesn't have a base specified, so we assume that the base is 10. So if the base of 10 is 10, the logarithm is the exponent, so the exponent is 4, and that equals x. 10 to the 4th is 10 times 10 times 10 times 10, which is, of course, 10,000. Problem 18 is another logarithm problem. And here we've got a base of 2, so we'll write it as the base. The exponent, the logarithm, equals the exponent, so that's 2 to the n equals 16 to the x plus 1 power. Well, the best idea here is to get 16, to get the base the same as this base. And in fact, 16 is 2 to the 4th power. 2 times 2 times 2 times 2 is 16. And now we're going to raise that to the x plus 1 power. When we raise a power to a power, we multiply them together. So this is going to be 2 to the 4x plus 4, and that equals 2 to the n. Well, if 2 to the nth power is the same as 2 to the 4x plus 4 power, that means that n equals 4x plus 4.